and CD is 3. So it will be 1, 3. For at 2, it will be BC, but D is not completed, right? So here I will insert the -1 because -1 is the least value. Because when you lexicographically, B is smaller than BC. So if you give a -1 value there, it will be smaller than anything. So BC will have a value of 2, -1. So CD will have the value of 3, -1. So these tuple, I will again sort it in quicksort. So this will give me the PI for all 2's. So now can I build for k equals 4? Okay, I need a better example to show where it is flat.
Because it's already sorted.
It's already sorted. Okay.
Give it as CDAB. ACDAB.
Okay. ACDAB. Sorry, my bad. I should take it. Do you guys get it intuitively how this thing will work? Because, okay, I want this value, right? Pi of k plus 1. So this is nothing but Pi of k, like the string starting from I of 2 power k characters, and it will be Pi plus k of k, like I plus 2 power k. Like this string will end at I plus 2 power k minus 1. The next string will start at I plus 2 power k till the full word. So that will be I plus 2 power k plus 1. So this is how we will split the word. So I know the value, I know the position in this, and I know the position of this. So for every suffix, this will be a new 2 tuple. I only want a 2 tuple, and let us say if the first tuple for some suffix is x comma y, and for another suffix is let's call it a comma b. So what will be the new position? If x and a are equal, if x or a are not equal, then whatever is smaller of these two, x or a, that will be the position. But if x and a are equal, I should have compared with respect to y and b, right? But I already have this information because I already solved for k equals I. Now I am at k equals I plus 1 now. This y and b, I want to compare which is greater, y or b. So that thing would have already been solved for p I plus 2k of k. So if I sort based on this tuple, I will get the new positions based on k equals I plus 1. I have to do this till k equals n. And whenever I can't complete this thing, I have to put it as -1. Because it's not completed and it won't affect the rankings. So let us build it for, what is the example? CBA.
ACB.
I'll give CAB.
Okay. DCAB.
DCAB. Okay, for DCAB, the suffix order. I start with the suffix. DCAB. So initially the suffix order for k equals 1. So initially I store the value of the suffix order itself. So in the next step, I should come, okay, I have to repulse this. So for k equals 1, I will compare DC, CA, AB. So what will be the order of DC, CA and AB? AB will be first, CA second and DC third. So technically this will start here, like AC will come here, then CAB and then BA. And I draw the table itself. So it is P0 of 1. So P0 of 1 was this way comparing the first 2 characters of the 0th string. So DC. So DC will have the rank of 4, right? And this will have the value, tab will have the value 3, this will have the value 1, this will have the value 2 in one based order. So based on this order, if I sort, this will get reversed, right? So the new order will be the second string. So AB will come to the front, then there will be then there will be B, then there will be CAB, and then there will be DCAB. So again I have to go for k equals 2 because there's a word DCAB, that is the lengthiest word, longest word. So AB currently has the value of, so AB will have the value of, this is 1, right? It will have 1 comma minus 1, because I am comparing for k equals 2, that is AB. So for k equals 2 should have been 4 and 2 here, but this 2 is missing because this is actually smaller suffix. So this will have a value of minus 1, and AB will have the current quotient, this is nothing but 1. So 1 comma minus 1. Then this is second one is B. B is not even complete for k equals 2. So this will have the value of minus 1 comma minus 1. Then CAB will have the value of, the CA has the value 3, right? So this is 3 comma minus 1, and this is 4 comma AB is 1. So if I sort this again, the order won't matter, because it is enough to just sort it by k equals 2, because most of the suffixes are not even that long. So if I build it for all the k, from log n till 1, for each k I have to solve it for each I, right? So I will be from 0 to n minus k at each step. So what is the total complexity of this building? Of n log n. It will be actually n log n square, because I have to sort these tuples. That will be another quick sort. So it will be n log n for the step alone, and another log n for sorting these tuples for k equals I plus 1. So n log n square, and this is actually the simplest construction of suffix array. If you want to speed up, instead of using a quick sort here, you can use a radic sort. Radic sort will have more it will have constant based on the base alone. So it will be nearly constant, it will be of n log n. So this is your wish, but this is the most widely used construction of suffix arrays. But suffix arrays as itself, right, they don't tell a lot of information. We have to build another auxiliary data structure called as LCP. LCP is called as the longest common prefix. So I have to build an LCP array, because the problem with suffix trie was it had a lot of use, but to make it memory efficient I have to do a lot of steps. But suffix array is simpler. I have to just store the suffix positions which is in sorted order, but building that will take all these values. So this P will be nothing but P of n comma k. At the kth step, what is the position of the ith index suffix? So the P of n comma log n